We are live. So chaos
I'm
has,
drifting, aren't I?
yeah.
It's okay. Like every time I swap my memory card on the camera, it pushes it like a little bit to the side.
Oh
So
man, that's a special kind of frustrating. I
it's
understand
fine.
it deeply, but
Yeah, yeah,
it's
yeah. And the worst case is that the tripod that's on it is like hanging right at the edge of the desk that I'm on, and so
oh
it has
geez.
fallen over the back of the desk every now and then.
All
We're all just
right.
existing in a house of cards.
Yeah, and my goal right now is to just get up Trello so that we can talk through, change whatever we want, upcoming
Hmm.
show schedule. For the very simple reason that my tech is not trustworthy today, and I am waiting
Yeah.
for an Amazon delivery that did not get here in time.
Right. So
So,
you've got a fix for your microphone and a fix for your camera coming.
yes,
Right. And so
yes,
instead, we're just going to hang out for an hour. Um, I suspect there'll probably be a couple of rants in there.
yeah,
And then we will uh, wrap things up. And then we're going to come back tomorrow.
yes,
Same bat channel, same
yep,
bat time.
yep. New YouTube link.
So
I will.
I've got a meeting tomorrow at 11. So this time tomorrow. So I can't do exactly this time tomorrow, but
All right.
I could start it like as soon as that's over, or like
Let
11:30
me pull up my calendar.
or noon.
Hold on. So many windows, so many Chrome identities. I've reached the point where like I have the one Google Calendar that all the Chrome identities feed their calendars to. Yeah, my schedule is open tomorrow. What time would you like to go?
So noon.
Noon your time is 2 p.m.
Hmm.
here. Yes, that
Yep.
is fine.
Okay.
Okay.
All right.
So I'm gonna switch things over to Trello so that we
Okay.
can look at
This is a first.
ideas.
This
It
is a first. I've
is,
never done
but
this before.
it feels like it's a good idea.
Hmm.
Because,
Hmm.
like, I come up with show ideas, and you're like, I don't know what this means, and you change the show ideas, and then I don't know what it means, and iteration, iteration.
Hmm.
I'm pressing
Hmm.
transition. So
Yeah. Yeah.
here
So
are
you
the
get to double check
ideas.
our series.
Exactly. So, like, for today, what I had written down was consequences to breaking space law, like not registering your satellites, transmitting at the wrong frequency. And so my ideas for this one was basically stories from the trenches when folks did not do what they were supposed to do.
Hmm.
And the truth is, there's like I'm about to babble about the topic, so I'm going to hold that for tomorrow.
Right. Okay. Okay. And then we've got ideas and methods to remove space debris.
Mm-hmm. And then basically, we're just going to do a short sequence on satellites because 1 in 15 of the glowing dots in the sky turns out to be a satellite right now. That's a thing.
Um, and so, like, this is really about. Okay, see, so this is why you need me,
Uh
because
huh.
that's an obscure title.
I know.
So it would be something like how to see satellites,
Okay.
observing satellites. So we'll talk about
How about or
the kinds of
avoid seeing them? So,
sure.
how to see
Good
or
luck.
not see? Pick your
To not see
battles.
satellites, I guess move somewhere with light pollution. But yeah, so like just like even if you want to go outside and see satellites with your own eyeballs, or if you want to know what is that thing that you saw that flew overhead, how we can see Starlinks when they take off, the
Yeah.
International Space Station, tools like Heavens Above, and then some kind of really cool things you can do, like you can watch the International Space Station pass in front of the moon if you
Uh
go to
huh.
the right location. So there's some cool stuff to do
Yeah.
that. Um, asteroid early warning.
Yeah, did you see the amazing Jerusalem Post title that was corgi-sized meteor corgi-sized meteor, the mass of 4 baby elephants hits Texas.
Right. Yeah. I think if we're measuring things in corgis now, I'm okay with that.
Americans will do anything to avoid metric.
Yeah. Yeah. But so with the asteroid, there's been a lot of really cool stories that have come out where people are detecting these asteroids in advance. And the insight that I had in a recent story was that for the longest time, seeing a fireball was a freak accident. Like you were outside and you happen to be looking up and you happen to see a fireball.
Yeah.
But we're now getting to a time when they are a predictable event that you will know when and where a fireball is going to happen. And then you can go and set yourself up and look in the right direction and it will happen. And you will see a fireball kind of dependably. And we're just at the cusp of these cutting edge systems coming online because there are these big objects slamming into the atmosphere all the time. So it's pretty exciting.
Yeah.
So this I think is a very, hopeful story, but also quite useful personally.
Yeah.
All right. So
then
sure.
The states of water. This one's kind of weird. I had no idea how to title things. I'm not allowed to title things. But like there's been new research that found a 4th or 5th state of water that occurs when you beat the shit out of water at minus 200 degrees Celsius. And the new state has the consequence that when it releases energy and goes to a more crystalline status, it can cause quakes in icy objects. So there's like all this weird stuff we're realizing that water can do as it goes from different molecular structures, and this can potentially drive different forms of tectonics.
Apparently your audio is only left channel.
Okay, fixing.
But yeah, I mean, so like, I thought there were more than that. Like, I thought there were other states of like superheated ice beyond just like stuff that is under enormous pressure, but also certain kinds of temperatures. So I think there are other forms of ice. You might want to look into see how
Water
many
ice or other forms of ice.
Water ice, yeah.
Okay, I know there's 3 different forms of amorphous ice. Then there's multiple forms of crystalline ice. I will do more research.
There's ice 7.
I will learn new things.
Yeah, there's hold on. Oh God. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23 forms of ice.
Okay, we'll be grouping those into groups and
Yeah.
discussing them. All right, we will all learn new things.
Yeah, this sounds great. So that'll be some prep. So let's call that exotic forms of ice.
Okay. And I'm going to leave my notes so I remember what all I wanted to talk about.
Yep. Okay. 23 forms of water ice. Yeah, there is. There's an ice 9, an ice. What is ice 9? I mean, ice 9 came from Kurt Vonnegut book, but ice 9 is a tetragonal phase formed gradually from ice 3 by cooling it from 208 Kelvin to 165 Kelvin, stable below 140 Kelvin, and pressures beyond 200 megapascals, and 400 megapascals. Had a density of 1.16 grams per centimeter cubed, slightly higher than ordinary ice. Okay. Oh, see, so like this is a pop culture reference.
I'm guilty. I know.
I don't like it. I don't like the.
All right.
I don't like puns. I know it ought to be there, but so
Can't you in your head like see
other.
all the dancers doing the dance now, except they're like asteroids with hula hoops?
Yep, it's overdone. I am like a sledgehammer. I like to just stay really so things with rings.
Okay. All right.
Other things with rings. So that way people are like, okay, so it's not the big planets.
Okay.
There you go. And then we can also include like there's a couple of like exoplanet candidates and some other interesting things with rings. So we could, there's we could also like mention accretion disks and things in case we sort of get bored of just asteroids. So all right. So the importance of dust. So let's call it it's always dust.
All right.
Yeah, that's the.
Did you see the special issue of AppJ Letters that came out last week focused on JWST that was like polycyclic aromatic hydrocarbons, polycyclic aromatic hydrocarbons?
No.
It was glorious.
Oh, wow.
All the dust.
It's always ice. It's always dust. It's always dust. It's always dust.
See, now I want to say it's always dusty in the disc or something.
Mm-hmm. It's always dust. Yeah, because it's always dust. All right. See now we're talking May 1st. That sounds like a title I'd give. High velocity stars.
Yeah, well, you did. I asked you for ideas. That was your idea, and it was a good one, so I kept it.
Yep. So we can talk about the hypervelocity stars. We want to stick with just high velocity. You want to go all the way to hypervelocity? It's your call.
I'm gonna do high.
Per?
I know that's not how it's spelled, but
I know. That's pretty cool. I like it. All right. And then we're gonna do rogue black holes.
Yep.
And then, so we don't even. Why say other stars that share mass? Just kilonova. The kilonova.
Okay.
The kilonova.
Fine. Yes.
Yeah. The kilonova.
Okay.
Yeah. Yep. Ultra low mass luminosity galaxies.
These are the ones that alternatively have no dark matter or are almost entirely dark matter. And it's super weird that it is one class of galaxies, but it's starting to make sense now that we understand them more and more within the context of galaxy mergers and collisions.
Yep. That's fine. I like it. It's very specific. Cosmic Dawn. Again, it sounds like a Fraser title. All right, this sounds like a Pamela title. Weird ideas and relativity, cosmological coupling of black holes, and what else? So, do we want to touch the dark energy black hole theory with a 10-foot pole yet?
Everyone keeps asking about it, and I figured that we could basically do a roundup of things that have potential observations but may have different interpretations needed.
So what else have you got?
So people keep predicting that there should be different magnetic field bits and pieces. That's all I can remember at this moment in time.
Right. But do you feel like
I can get rid of that.
Well, so the thing that would be interesting to talk about, and I don't think we've really talked about it yet, is like this new. You've heard about this universe breakers galaxies, these 6 galaxies that are bigger than the Milky Way.
Yeah,
but
that came out last week, didn't it?
Yeah. So this is this story of too big, too early.
Okay.
So, and that's what we call the story on Universe Today, but the gist being, uncertainty in cosmology.
I'm just gonna do too big too early
Yeah.
and kept growing.
Sure.
Um,
Yeah. Yeah. So I mean, I think the story is definitely growing that there are large galaxies being found too early on in the universe, and it's going to require like this latest one like overturns like 99% of current cosmological early universe evolution
yeah,
theories.
yeah. Lambda cold dark matter isn't surviving so well right now.
Hmm. Hmm. The permanently shadowed craters on the moon. So did
Okay.
you want to talk about? I mean, there's stuff on Mercury too, but permanent shadows. How about that? Permanent shadows.
Okay. Yeah, I figure with Viper gearing up to launch, of course, when I wrote this, it was a lot closer to launching than when it is now. Permanent shadows.
Yeah, I like that. Zero G manufacturing. Prepping for the moon. So specifically, we're going to talk about all of the missions that are going to happen before the humans return.
Yep.
Okay. And then looking ahead.
Yeah,
Then the summer hiatus.
it is. Does this look good to you?
Looks good to me, but I'm hoping the audience would
Okay.
have any kind of question or confusion or um,
Pulling up the chat.
so Lionel KGOFH is saying that Dr. Becky gave a big I have my doubts about it. Yeah, in Dr. Becky's video about she included as a piece of news, and so did Sabina Hassenfelder, and both of them gave a fairly skeptical approach.
I don't.
My favorite was Ethan Siegel's. He wrote a fairly extensive blog post about it, and he's skeptical too because it's such a dramatic claim
Yeah.
that dark energy and black holes are connected. But he feels that the correlation between black hole size and dark energy strength are pretty good. Oh, wait. Beth is saying we should put permanent shadows and prepping for the moon back to back, and she's exactly right.
Okay.
Yeah. Looks good, but be flexible because new things might come up. So the correlation, correlation is not causation, but the correlation is surprisingly tight. 99.98%.
So the thing that it reminds me of is back in, I don't remember if it was 2000 or 2005 or 6. There was a journal article that the author struggled to get published. New Scientist covered it, making it their cover story. It was Copenhagen overturned, where there was a researcher showing that you could simultaneously measure the particle and wave nature of interfering particles. And so the question became, is it that the wave particle duality rules that we'd always said we had, if you can detect either it being a wave or it being a particle, are foobarred, or is it a matter of we don't have a correct interpretation for what we're seeing? So the observations were very, very clear. But the interpretation is where things got argued about. And so what I'm wondering is, are our observations that apparently elliptical galaxies, supermassive black holes keep growing for unknown reasons, is not cosmological coupling the way it's being described as a source of dark energy, but is it something else that we just don't understand?
Mm-hmm.
And one of the other myriad, this week's theory of dark energy, is actually the real source of dark energy. And I'm voting for something weird is going on, and dark energy isn't black holes.
Yeah. So, I mean, this was the comment that Dr. Becky made in her video, which is that this this falls exactly in her wheelhouse, black holes and dark
Yeah,
energy.
yeah.
And the, like, having a black hole grow 8 to 20 times its size over the course of some amount of billions of years without access to readily obvious
Yeah.
sources of fuel is incredibly surprising. And this
Yes.
is the kind of thing that is going to need some kind of explanation. And this isn't new. This has been known for a little while now. And so what's making that happen
Yes.
is very, very interesting, and means that we don't understand, like if they're not coupled, then it means that we don't understand how black holes grow at the most fundamental level. We don't know how they grew early on, and we don't know how they grow later on. We just don't understand them.
Correct.
Even though we know they're there, and we can measure their mass, and we can measure their spin rates, and we can watch chunks of material fall into them, and we can see them on collision courses, and as we will talk about later on, we can see them on rogue trajectories. We don't know how they grow, but it is a lot. Like, to have what should be a galaxy no longer merging with any neighbors, still able to grow 8 to 20 times over the course of a few billion years is
wild.
Phenomenal. Yeah, it's wild. It's crazy. Yeah. So that is, I mean, I'm not a scientist, but as a journalist, I've had it beaten into me by my scientist friends that being skeptical should be your default position when you hear any of this stuff. And I really love the quote from Paul Sutter: "If it's interesting, it's probably wrong." Right. And both of these are interesting. This research is interesting. And I had a chance to interview the researcher. The researcher is behind it. And we talked about it. And we sort of spent the first half just like all of the findings, measuring this coupling quantity, etc. Once we moved into the why this might be happening, now we're just in dreamland, right? Who knows? So.
Yeah. The universe is just weirder and weirder the more we look.
Yeah. Like, let's say that this stuff is true.
Yeah.
Let's say that there is some connection between dark energy and black holes. And even if it's not causation, even correlation is weird.
Yeah.
The amount of dark, like that some mechanism is feeding both creating dark energy and feeding black holes. That we're seeing galaxies the size of the Milky Way 500 million years after the Big Bang, that we are seeing a different measurement rate for the expansion rate of the universe early on in the cosmic microwave background radiation and in more recent objects. What does this mean? We can't find a particle for dark matter
right.
in our particle accelerators.
Yeah.
What is this all? What if this is true? What does the cosmologist in you feel where this might be heading?
So I'm an observationalist. I am tried and true observationalist, and I read a lot of the theory papers, and I let myself get excited about the theory papers. But at the end of the day, the universe is going to show us what it's about. And if we can't see the details in our theories played out in the reality of the sky, our ideas are wrong. So,
like, what gets overturned, I guess?
I think that something's going to come out of the particle physics side of things. One of the frustrating things that I also take delight in is we have not been able to come up with a theory of particle physics that starts from first principles, gets only the particles we've been able to detect so far, and doesn't predict a bunch of particles that we should have detected and haven't. And so this tells me that there's something in how we're thinking on the quantum mechanics side that probably isn't right. There was
Hmm.
a paper a couple weeks ago, I think, on how if you look at the way vacuum particles pop in and out of reality and exert some sort of a polarizability onto the particles, you can change the vacuum energy to make it match dark energy. So we have one theory there that is adding to particle physics. We have seen other theories that, I mean, it's literally becoming the theory of the week very much.
Mhm.
And each of them seems to make equal sense with what we have right now. And
Yeah.
and so it's like we're in this unconfined state. And that's terrifying and amazing simultaneously because we just don't know. And part of me really fears for graduate students of the future because the math that's coming is going to be super ugly, or we would have figured it out already. And I'm glad I'm not going to have to do their homework sets.
So, I mean, what do you think are the firm foundations, the things that we can be certain of? Like, we can be certain that the universe is expanding.
Yes.
We can be certain that the Big Bang Theory is largely true thanks
Yes.
to all of the independent lines of evidence. So,
Mhm.
what we see as the observable universe today was once the size of a grapefruit.
Yeah. And where things seem to be going slightly sideways to very sideways is in what prevented or accelerated the collapse of the tiny irregularities in the mass density of the universe early on. And so it appears now like things were able to collapse significantly faster than our understanding allows.
And so, like, one possibility is this idea of primordial black holes.
Mm-hmm.
All right. They would explain dark matter. They would
Mm-hmm.
explain supermassive black holes getting big quick.
Yep.
The other possibility is the direct collapse black holes.
Yeah.
Those would explain supermassive black holes getting big quick, but they don't shed any light on dark energy or the crisis in cosmology or any of that.
Yeah.
It's got to feel weird to be an astronomer, especially a cosmologist right now.
Yes. Yes.
But like, wasn't this the job of JWST? Like, wasn't this its job to? I mean, I think
So
when they built. Oh, go ahead.
We didn't expect the current amount of garbage that we're dealing with. So JWST, which was slated to launch 2000 aughts.
6, yeah.
Yeah.
8,
Its justification was it is going to allow us to see back to the age of reionization and understand what initially made the universe transparent and how galaxies initially formed. It was also supposed to help us understand star formation. And there, I think it is doing its job without creating extra confusion. And as we got better and better with exoplanets, it was going to be observing exoplanet atmospheres and pushing the field of astrobiology forward as we're able to see what it does and doesn't exist in other atmospheres. Now, those different things don't say, and it will explain dark energy. WFIRST, which is now the Nancy Grace Raman telescope, was always said to be, this is the one that's going to take on that problem, along with the dark energy camera that was installed, I believe, in La Palma. I could have the wrong observatory there.
I know the one in South America. Yeah.
And then the Hobby Eberly Dark Energy Explorer spectrograph was another one that was supposed to be doing major work to figure out dark energy. Now, side by side with all this work that we're doing in just trying to measure over time the expansion of the universe, it's just kind of a hot mess in terms of we keep seeing things that don't fit what we were planning to prove
Mhm.
or disprove. And
Yeah.
what do we do with that?
Right. I mean, when you think about the Large Hadron Collider, its job was to find the Higgs boson, and it did it. It did it, finding it almost exactly where it was expected to be, with almost exactly the mass it was expected to be, and it hasn't found really anything else. It didn't extend physics in the way that particle physicists were hoping. So it nailed its job.
Yeah.
And was that the expectation that JWST would nail down? Like, you have these various ideas for early universe, building blocks, dwarf galaxies, da da da, and they would be like, well, it's this theory over that theory,
So
and it's going like, they're all wrong. Sorry.
we knew in the early 2000s that it was starting to look like galaxies were forming both top down and bottom up. So from small things grouping together into larger and larger, and also from massive things just collapsing full force. The time scales that it was happening on, we were just wrong. Just wrong. And so that is utterly unexpected. And when JWST was getting built, it wasn't known that there was this Hubble crisis, Hubble tension, whatever you want to call it. And so the Hubble tension really started to show its angry face 6 or 7 years ago, as the error bars got smaller and smaller, and every year it just sort of becomes more of a looming mystery that threatens lots of ideas. So when you have something like the Hubble tension that post dates JWST, you can't really say JWST was designed to solve it. It might be a useful happenstance that it solves it. We're just going to have to see. We live in interesting times. Take that how you will. I'm glad I'm an observer.
Yeah. Yeah. But I mean, you definitely get the sense of excitement and enthusiasm from the astronomers. I mean, they're stoked that all this is happening, that it's so interesting. And especially for new people coming into the field. Like, it's wide open now. All of these established theories are just they're just not providing the evidence. They're not matching the plans. So
yeah, it's wild. It's a wild, wild west out there.
So someone's asking, Googler is asking, how big was the cosmos 13 billion years ago? So I wonder if there's a way to do that. Let me see.
Your Google foo is better. I'm going to let you figure that out.
Yeah. Well, Ned Wright's got a great cosmology. So, okay. Cosmology calculator. So Z3. So that's not, we want Z10. A billion years after no, that's not it. 8. Close. 7. 6. There we go. 5.9. Okay. So at 13 billion years ago, the universe was 27 billion light years apart. So it was 54. So 13 billion years ago, the cosmos was 54 billion light years across.
Okay.
The co-moving volume within redshift Z is 2,467 billion cubic parsecs. And the angular size on the sky would be 4 billion light years across.
That's tiny.
compared to what it is today. But that was,
Yeah.
900, 800 million years after the Big Bang.
Yeah.
Zephan is saying, did black holes eat dark matter maybe?
Did what eat black?
Did black holes eat dark matter maybe? Like, is that how you could explain black holes getting so much bigger?
So the idea of cosmological coupling, as best as I can understand it, is the vacuum energy of the universe is such that as the universe expands, the amount of energy per cubic meter stays constant. And black holes, because they're embedded in the fabric of space-time, have an ability to essentially the amount of energy that they can access increases, and that in turn causes their mass to increase. And this in part has to do with particles forming inside and outside of the event horizon. But I need to go do a whole lot more research before I say more than that.
Mm-hmm.
You've read more on this than I have so far? I've read a couple of the
I don't know. I
papers.
don't know if any, yeah.
Okay.
I mean, from what I understand, dark matter has too small of a cross section for it to clump up and go into black holes in any reasonable amount.
Yeah. That isn't the concern. The concern is more that the energy is that explains dark energy is being given off.
Mm-hmm.
I didn't fully understand the maths. I need to try again.
So Googler says, could a smaller cosmos make star formation easier? Yeah,
Yes.
when the universe was smaller, star formation was easier. And in fact, the peak of star formation happened in like 3 billion years after the Big Bang, and it's been just declining ever since. Okay. Well, so why don't we wrap up for today then?
Yep.
And then we will be back tomorrow at noon to record the show, assuming you get your
cables.
Assuming you get your cables.
And
everything's ready to go.
A camera that doesn't make me look slightly pale blue. Yeah. I literally have a crappy camera sitting on top of a very good camera that doesn't have a very good cable.
Right. Good luck.
Thank you.
All right. Thank you everyone for hanging out. I know this was a non-standard show, but we wanted to give you something. But now you helped us choose what the upcoming shows will be.
So welcome to a double feature week, I guess.
Yeah.
We will see you all tomorrow.
All right. Thanks, everyone.
Bye-bye.